So where chapter 11 was about talking about sampling, now we're going to figure out what to do with our samples. We're going to run experiments. And this chapter is designed to go over how to design experiments. So we'll need to go over some vocabulary because it's very vocabulary intensive. What do I mean by an experiment? An experiment manipulates factors levels to create treatments, randomly assigns subjects to these treatment levels, and then compares the responses. Now what do I mean by factor and levels and treatments? A factor is a variable whose levels are manipulated by the experimenter. Experiments attempt to discover the effects that differences in the factor levels may have on the responses of the experimental units. Level is the specific levels that the experimental chooses to factor. Treatment, the process, intervention, or other controlled circumstance applied to the randomly assigned experimental units. And the response variable is a variable whose values are compared across different treatments. Now, unlike you, or maybe like you, I prefer pictures. So, this whole thing I'm doing is an experiment. Factor is I have different levels within these factors. Notice, what am I trying to experiment? I'm using a treatment here. This treatment I'm calling X is chocolate cake. This treatment here I'm calling Y is caramel cake. This treatment here, Z, is lemon cake. So treatment are different types of factors, and what is my overall factor? It's the type of cake. So all of this is my experiment. My factor in this experiment is I'm testing types of cakes, and I'm testing their taste score. Each of these different types of cakes is called a treatment, and there's also, within these, is a level. So my chocolate cake is level 1, caramel cake level 2, lemon cake level 3. And if I had more different cakes, I'll just have level 4, 5, and 6. Now, what am I trying to gain from this? I have these people eat these chocolate cakes, and my variable, my response variable, is their what? Taste score. So that's experiment. That's what I mean by your factor. What is it you're trying to manipulate? I'm manipulating the types of cakes, right? My treatment is the different types of cakes. And then my response variable is their score. And then each of these are considered levels that make up my factor. So pictures help me out a lot. I hope that this helps you with that vocabulary. Humans who are experimented on are commonly called subjects or participants. Other individuals, like rats, days, bacteria, and a petri dish, are commonly referred to as experimental units. So when you hear me say subject or participants, we're talking about people. Everything else is experimental unit, like dog, cat, whatever. Blinding. Any individual associated with the experiment who is not aware of how subjects have been allocated to treatment groups. So it's very important that we not only randomize, but we also blind them from our subjects. We don't want them to know that I'm trying to figure out which cake is the best. Maybe there's some kind of bias there. Ooh, I like chocolate cake. So I'm blind them. Try this cake. I think it's chocolate, but I really do like the taste. Try this cake. Oh, well, it may be a different type of chocolate, like dark chocolate. Name another one. What?
Milk chocolate.
Milk chocolate. Very good. And there's what's another one? White chocolate. So you're testing different types of chocolate. They see it all as a black chocolate cake. They just don't know the different types. You're trying to figure out maybe more people like dark chocolate. So that's blinded. There are two main classes of individuals who can affect the outcome of an experiment. Those who can influence the results, so like the experimenter. Say I give you a little bit more chocolate in that dark chocolate cake. Like I'm trying to influence people to like chocolate cake. Or people that, they kind of know what's coming. Like you didn't blind them. So they're like, ooh, I like that one. What else? That's all the examples I can think of. And those who evaluate the results. So somebody could say, ooh, I'm going to sway these results to lean towards milk chocolate cake. However you can manipulate. When every individual in either of these classes is blinded, an experiment is said to be single blind. So if I chose just to blind the evaluators, that's a single blind. When everyone in both classes is blinded, we call this a double blind. So both of these people are blind. So the person who's running the experiment here doesn't know which cake is which. right? He doesn't know which one he gave the participants. He blinded himself to prevent that bias. And then the people who are trying the cake, again, they don't know which cake is which. So that's why it's important to blind. Not just a single blind, but double blind. That way both the experimenter and the experimentee, kind of can influence the outcome. So there are 4 main principles of experimental design. Must have control. Control aspects of the experiment that we know may have an effect on the response, but that are not the factors being studied. When creating a control group, the experimental units are assigned to a baseline treatment. The responses provide a basis for the comparison. Later, I'll talk about placebo. They're given a known, just plain old baseline. They don't know that they got the special drug. They just got some drug that doesn't have any kind of side effects. So we're kind of blinding them there. So we want to have control over that. Randomize the subjects to treatments to even out the effects that we cannot control. So again, it falls in our sampling here. Randomizing our sample. In a completely randomized design, all experimental units have an equal chance of receiving the treatment. So you just don't want to give all females a placebo and all males the actual drug. You want to make sure you have all of those have an equal chance. Replicate. So don't just do the experiment just one time and say, yep, there it is. Replicate over as many subjects as possible. Results for a single subject are just anecdotes. The subject of a single experiment are not a representative of the sample of the population of interest. So as you'll get into grad school and even higher than that in education, you'll do lots of experiments, lots of journals. You'll see people have done the same thing over and over and over again. It's like, what's the point? Somebody already did it. Well, the point is replication. Block. To reduce the effects of identifiable attributes of the subjects that cannot be controlled. And I'll explain block here in a minute. Control. One way we can use control is what's called a placebo, a treatment known to have no effect, often given to the control group. So the most common example here is drugs, medical pills. You want to give your control group a placebo pill, a pill that doesn't do anything. Usually it's just a sugar pill. And then you want to give them the Tylenol, the actual drug you want to see if it has the effect you're looking for. A placebo effect is the tendency of many human subjects, often 20% or more of an experimental group, to show a response even when you administered a placebo. What's some Tylenol? Here's some Tylenol. And they take sugar pill, and they're like, oh, my headache went away. If you know me long enough, I'll probably give y'all plenty of placebo effects in this class. Discuss. Randomize. Random assignment. To be valid, an experiment must assign experimental units to treatment groups at random. Kind of speaks for itself. We talked about more of that when we talked about sampling. Confounded. When the levels of one factor are associated with the levels of another factor in such a way that their effects cannot be separated. So if you run an experiment on alcohol use and lung cancer, one of the confounding variables here is smoking. So what can we say about smoking? Well, if we found that alcohol use kind of leads to lung cancer, was I able to control whether or not those subjects were smokers? You don't want to have that confounded. Also, we saw a lurking variable, going on in there. Blocking. When groups of experimental units are similar, it is often a good idea to gather them together into blocks. By blocking, we isolate the variability attributes to the differences between the blocks so that we can see the differences caused by the treatments more clearly. So why would you block the design? For one, say you're trying to test the drug, and you want to test the drug, see its effect on men and women. So you block your subjects between men and women. Also with sampling, we saw this, and it was called what? What type of sampling was this? Stratified, very good. This is a stratified sample. Put it, as far as experiments concerned, a stratified sample is called blocking. So when we're talking about experiment, stratified is blocking. All right.